Hello, it is October 3rd, and we are going to be talking about the strength factors affecting aerobic running economy. First, we're going to talk about what it is, how it's measured, and why it is significant. So, what is running economy exactly? Well, at face value, running economy appears to be a pretty simple concept. It mainly describes how little energy is needed to maintain a specific running speed. So in the same way that one car model versus another traveling at the same speed with the same tank of gas and the same engine size can achieve a much higher mileage per gallon. Or you can use the example of an LED versus an incandescent light bulb, which could emit the same amount of lumens for much longer, provided the same wattage. So runners with a well-developed running economy spend less energy and require less oxygen to maintain the same amount of force production moving them forward. So specifically, running economy is going to be measured using the metrics of milliliters of oxygen consumed per kilogram of body weight per minute. And this is going to be done using spirometry, which is a test to measure how much oxygen you're breathing in using a mask like the one pictured above, that is literally breathing your volume of gas exchange while you run on a treadmill at a set pace for a set time to create a normal value based off of your body weight. So what exactly is significant about these magic running economy numbers? Well, as you can see here, we could make useful tables that predict the running performance of an athlete based off of their consumption of oxygen at the same working speed of other athletes. But what I think is more interesting, rather than these predictive values, is how we've made massive inferences on the variables that affect running economy in research simply by using these numbers and seeing how they change in response to the numerous different demographics of runners. So it's easy to believe that elite aerobic distance runners kind of trend towards these lower numbers, but what's more fascinating is how can we affect the variables that are going to play into this, and specifically how do our strength training programs affect such a aerobically dominant metric. And by the way, if you happen to fall into the camp that thinks aerobic training requires no formal strength training for optimal performance, then I would like to remind you in the least patronizing way as possible that you still have to go fast to go fast. And to make that point, I introduce Eliud Kipchoge. If you don't know him, he's the first human being to run a sub 2 hour marathon in a non-sanctioned race nonetheless. But if you haven't tried running a 4:34 mile for even a quarter mile at that pace, then go ahead and give it a whirl. It won't take you very long to realize just how considerably strong you need to be in order to sustain 13.14 miles per hour at any given duration of time, let alone for nearly 2 hours. So there's no mistaking that a baseline degree of strength and power is required to run at such speeds, but what factors of strength training play into running economy specifically, amongst all the other factors that seem to change that variable? Because running economy is such a heavily researched topic, there are just such a huge range of variables that play into this, and to adequately cover all that influences it in 10 minutes is a futile undertaking, to say the least. We've got, everything from energy efficiency at the cellular level, cardiopulmonary interactions, how we organize training and programming and the environments and all that such. Biomechanical, like structural effects, and how the neuromuscular system communicates with everything. It's just too much to grasp. So what we're going to do is narrow this down to just a few factors that we can primarily affect in our strength programs. To keep things simple, I have outlined 4 areas that have been shown to make the greatest strides in running economy. And this is not an extensive list, but I would argue that these 4 are one of the most trainable factors that we can discuss today. And they are kinetic stability, dynamic strength and mobility, plyometric adaptations, and neural adaptations. And they all play off of each other and interweave in unique ways, and we'll get into that next. So the first area here is kinetics, and specifically the kinetics of the human body. And this animation really shows you how mind-bogglingly complex the motor patterns that keep the skeletal structure rigid enough to propel us forward are. The main concepts at play here are just how we can develop a better strength of the musculature supporting the skeletal structure so that we can have this nice, strong platform to launch off of. And then also how we can minimize any excessive work being done by weak muscles that are causing these uncontrolled motions as a result of the forces being put on it. So in order to train kinetic stability in a running specific way, we need to know what kind of forces are at play specifically to the body in each step, so we can counteract these forces with the prepared musculature that has been strengthened in our strength programs. Some of these directions are going to be rotational stability about the ankle and femur and the lower back and upper back. We've got lateral stability that's going to be needed to combat the forces as we switch from leg to leg. In the pelvis and in the knee and in the spine. We're also going to have to combat the vertical compressive forces and be able to push off strongly against the ground up to 250% of our body weight, as well as the accelerative and decelerative forces in the sagittal plane that are going to be pushing and pulling us as we try to brake or accelerate with each step. But if we're just rigid objects and we're not able to move, there's going to be an issue in how we can effectively use the forces that we need to put into the ground into propelling us forward. So there are a number of dynamic movements within running that factor into better running economy and that will limit performance if the active mobility is not developed. For an example, here we have Mo Farah with an extremely exaggerated hip extension in this huge stride that he's performing right here. And a few other factors of this are thoracic rotation, shoulder extension, and knee extension as some primary factors of dynamic mobility in the running form. Next, I just want to quickly highlight how plyometric adaptations to strength training influences running economy. And the main point here is just that tendon stiffness increases as it's loaded in a plyometric way with heavy loads and explosive forces. We're going to get an increase in the number of tendon collagen fibrils, and this is going to increase its load capacity and resiliency, as well as the coordination benefits we're going to get from practicing these motor patterns, which is going to develop into a higher rate of force development and, most importantly, the lower ground contact time that we're looking when we're trying to put ground forces into the ground quickly and receive that spring-like pattern from the mechanical structures of these tendons. The final considerations here are the neural adaptations to strength training that influence running economy. And the first one that I'm going to talk about is how to maximize motor unit recruitment in order to develop the maximal amount of strength that one can without increasing cross-sectional area or muscle mass that would be a conflicting factor to running economy. So it's been shown time and time again that you can concurrently strength train and develop endurance attributes through endurance training, as long as there's a careful consideration on the focus of neural drive and neural adaptations from heavy weight training and a low volume during concurrent endurance training, so that we can increase the number of motor units recruited and not the amount of muscle fibers built upon. But here's the catch: if you're not able to build that force in less than a quarter of a second, then you're not exactly using the strength gains you just developed in the most efficient way possible to access the stretch shortening cycle in the window of time that it needs to to maximize the energy return necessary to create the most amount of rigidity and 100% return through that tendinous structure. So how we do that is through lighter explosive resistance with an emphasis on maximal velocity against that resistance. The goal here is to train a physiological process where you're discharging action potentials more frequently to create higher peak tension. It should also be highlighted in this section here to use multi-joint motor patterns when training for strength and neural adaptations, because these are going to be the ones that create the most crosstalk between motor units and motor patterns in the CNS in order to create the most effective synchronization or coordination of multiple different muscles having to work in unison, just like an effective pulley system here.